All right, so welcome. We are recording. It is Monday, the 27th of April. Happy Monday. We're happy to have you with us. We are deep in the conversation of weather products. Hooray, weather products. Last time we did some METARs and TAFs and printed weather products. As we continue on covering material, we're going to get to graphical weather products. Ooh boy, watch out. But before we get too deep in presentations, we'd like to say, good morning and, any general ideas from the class, anything going around anybody wants to talk about or bring up?
I do have one question. I was doing the chapter 7, Charlie and Delta, just short, not the short answer, but the homework questions. And for half the questions, it's asking to look at these figures. And anytime you try to look at the questions, the figures won't pop up. At least it's doing it for me. I don't know if it's been doing it for anybody else, but I've just been having a problem.
It says 0 points, so from what I understand, if it's worth 0 points, it wasn't really supposed to be worried about since he probably knew it was going to have that issue, I'm guessing.
Yeah, the problem is that the Blackboard course regenerates for semester to semester, year to year. And when this question regenerated this year, for some reason, it didn't bring the figure with it. And at that point, I didn't realize it was an issue until after the fact. So some people have already submitted assignments. And so I think it's kind of unfair for me to try to go back and change it and make people redo assignments. So what I've done in the meanwhile to make it more simple is exactly like Nick is saying. I would make it worth 0 points if it's an unfair question. If we ever have an unfair question, I'll make it worth 0 points. We got some people trying to get in here. Let me admit them, maybe Michael and Jacob. So here's Michael, and it was Jacob. Wheat. Okay. So for those of y'all joining us, if you are struggling with Chapter 7, C and D homework, you will find that there are some questions that ask you to reference a figure, but the figure is not loading, the figure is not working correctly. We are fighting technology. So the story is I've made those problems worth 0 points. What the lesson can be is that the question is still a valid question as you prepare yourself to, think about becoming a private pilot and understanding weather products. We should still know how to answer those types of questions, but unfortunately I couldn't supply the actual figure. What we will do is as we meet together in class here with our digital Zoom technology, I'll be sure to put some of those weather products up on the screen and we'll be able to talk and review some of that information. But because the homework had already been published to the world and some students had already completed that assignment, I'm not trying to make somebody have to go back and redo an assignment that they think's already done. I'm not trying to do that to anybody. So if it's a bad question, it'll be worth 0 points. You're going to find some of those. In the meanwhile, I will try to prepare you for that information by be sure to put it up in the PowerPoint presentation, which we'll probably get to today. Today we will finish printed weather products, and then we'll be getting into graphical weather products. So those graphic pictures that we couldn't get a clear snapshot of through the technology, we'll be able to look at them today and review. So hopefully that answers your question or clears up some of that confusion. I'm sorry you had to scratch your head and have that issue.
I appreciate it.
So here we are. Cool. Yeah, I had a few other emails about the whole Blackboard. It's a computer, it's a technology. I'm the human being. So whenever you submit an assignment through Blackboard, I get the notification, and then I usually wait until so many people have submitted. And after I get so many submissions, I'll go through and I'll start assessing everybody's answers to see if I think that students are on the right track, if students are getting the correct answers or not. Unfortunately, there's some of them that are very foolish, small things, not a big deal, like the word low-level wind shear. According to the computer, it thinks it's low-level wind shear with a hyphen, but some students want to put low-level wind shear with a space. It's not a big deal to me. I'm going to give you the points regardless, but you might possibly get the the answer back when you immediately submit it that it's an incorrect response. But don't worry, whenever I go back through, I'll see that you actually had the correct response, and I'll give you the appropriate points in the grade book. So for those of you guys doing your homework and moving forward, doing the right things, keep up the good work, do the things you're supposed to do. We're getting very close to covering and finishing weather products. And yeah. So we had a few extra moments for any people to get in. We saw a few stragglers hop in. Currently, I think we're still looking for Cameron Swank. Did we see Cameron Swank? Chance. Did we see Chance Manager? And then we're still missing Isaac Nesbitt and Jacob Helton. All right. So I'll click the button for finish attendance. It's still an open floor, an open conversation. If anybody had anything they wanted to bring up before we get into some printed weather products. Okay.
Yes, sir. Real quick, I emailed you back about that answer that the Blackboard didn't register. It was in reference to the winds aloft, and I believe I got it wrong. It said it gave you a description of the question. So like I wrote back that it was like 17.0 -1, and it gives you the answers in different formats, and one of them says that the information is incorrect. That's the answer that I put down. So just to clarify that up in the email.
Okay, yeah, so Christian's on top of it. He's doing the right things. He's doing his homework. He's writing questions to his instructor. And we have a tricky question about winds aloft. So I'll share that. I don't think Christian minds. Let's see. So here's what Christian's saying here. He says it's 170701. Is that what you guys see?
That was a sample question that I took up. I didn't know what
Oh.
the actual information was on the actual homework.
Okay, so maybe during the break, or we'll spend some, I can, when we're not, everybody's waiting on us, I'll figure out a way for us to do some more winds and temperatures aloft. In fact, maybe we should just go ahead and start with that. Let's start with some winds and temperatures aloft. That's a good strategy for us. So we're gonna start with some real world examples for winds and temperatures aloft to help out Christian, and then we'll work our way into our PIREPs, which is our printed weather products that we've been working on. So if I hit screen share and I do screen 2, so you guys are seeing Google. Yes? No?
Yeah,
Yes.
Okay.
Copy.
Okay. So you're seeing Google. So I'm going to start off by going to aviationweather.gov. Aviationweather.gov. When you get to aviationweather.gov, this is one of your favorite websites. On aviationweather.gov, we have, when I get on this website, I either usually go for forecasts or I go for observations. Those are my two main go-to tabs, menu drop downs. I'm gonna go to forecast today, and I'm gonna go for winds/temps, winds and temperatures aloft forecast. In the center picture is the graphic, and the graphic is interactive. You can click around on the interactive graphic. That's a really cool feature. Old school style, I'm gonna go down and click the printed product. And IND, this is us, Indianapolis, so I'll click Indianapolis. And it brings up winds and temperatures aloft for this whole entire region. Today, for example, we're gonna study Indianapolis. So here's the Indianapolis winds and temperatures aloft, and I'm gonna try to make this bigger for you. Control plus. All right, so here's a real world winds and temperatures aloft forecast for today. And they're telling us that in Indianapolis, at an altitude of 3,000 MSL, we are looking at a forecasted wind of 220 true, 10 knots. So 220 is kind of southwest. We think at 3,000 feet, the winds will be southwest at about 10 knots. At 6,000 feet MSL, where my mouse is hovering, at 6,000 feet MSL, we anticipate around the Indianapolis area, the wind to be 240 7 knots, and the temperature +1 Celsius. So again, it's still southwesterly, possibly getting a little more westerly. And now we're getting temperature information. All right, we're happy to have Cameron join us today. I'll click the button here to give him the tardy symbol instead of the absent symbol. We're happy to have you, Cameron. Cameron's joining us, and we are studying winds and temperatures aloft forecast. And one of the big lessons you're getting out of this example is that when you're within 3,000 feet of the surface, the product does not predict temperature. When you are within 3,000 feet of the surface, the winds and temperatures aloft forecast does not predict the temperature. If you want to know information about within 3,000 feet of the surface, you might be better off to look at a different weather product. So really, you're really seeing a true picture. Remember, we talked about how the winds aloft are not the same as the winds at the surface. The difference of the friction force versus the Coriolis force, you know, the impact of the upper air jet stream. Lots of different variables are going to affect the winds for different altitudes. For you as a pilot, why is this important information? You might be planning a long cross country. Let's say that we want to do a long cross country straight west. We want to go straight west. And so you would analyze this weather product and you can see that, hey, at 3,000 feet, the winds are from 220. 6,000 feet, they're from 240. 9,000 feet, 280. 12,000 feet, 300. So you can see that the closer you are to the surface, the more the winds are southwesterly. Whereas the higher in altitude we get for our airplane, the more the winds turn to be northwesterly. So all of a sudden, if we wanted to go straight west, we might want to avoid this altitude of 9,000, this altitude of 8,000, because that might put a perfect headwind. In the real world, it's not a big deal. A little bit of headwind's not going to, you know, totally hurt us. But imagine if it was a very long trip and a very, you know, heavy aircraft that consumes a lot of fuel, it could really add up to try to avoid headwinds when possible. If you got to have a headwind, you got to have a headwind. But if you had your choice, you would rather have tailwind over headwind, or at least minimize the headwind or maximize the tailwind. So these are some of the considerations when you're trying to choose different altitudes. And this is a weather product you would use, winds and temperatures aloft. Remember, every time that you look at a weather product, it's really actually best to start with the top, the header, the information about that weather product. So this weather product is telling us the data is based off of observations from the 27th day at 12 Zulu. And then they're saying this actual forecast is valid the 27th day at 18 Zulu. We're supposed to use it between 14 and 21 Zulu. That is the time period that this data is actually forecasting. And then, like we said before, if you get above 24,000, call that flight level 240, it will be assumed that the temperatures are negative. There will be a test question about that. It'll ask if you're exactly at 24,000. Well, if you're exactly at 24,000, you would still expect to get the negative symbol for your temperature. It's not until you get above 24,000 that it's assumed the temperatures are negative. So this has been us reviewing some winds and temperatures aloft information. Today is not a very strong windy day, so we are not seeing any of the crazy strong wind examples like we had before. If you had crazy strong wind examples, the coding changes and they add 50. They add 50 to the wind direction and they subtract 100 from the speed. So we went over that last time and I did the math. If somebody really needs to hear or see it again, that's possible. This has been a good review of printed weather products, winds and temperatures aloft. As we continue moving forward, we could take a look at PIREPs. Hooray, PIREPs. All right, so everybody should be seeing a slide for PIREP. We got our brain warmed up. We've been analyzing printed weather products. So this is a printed weather product called a PIREP, P-I-R-E-P. That stands for pilot report. So it starts off with UA. UA, you can think means upper air report. This pilot Is this review? We didn't cover this last time. I think we left off right here. Yeah. So somebody stop me if this is wrong, but I think this is where we're at. UA is upper air report. OV is describing the location. So OV, this aircraft is over OKC area. OKC would be the Oklahoma City. Radial 063, that's like off the VOR radial. So 15 degrees, 15 miles, I said it wrong. It's 063 degrees, 15 miles. So call that east, northeast. So this airplane is near about 15 miles east, northeast of Oklahoma City, VOR. TM time, this pilot report gave this report at 1522 Zulu. FL flight level, that'll be the altitude. The pilot gave this report from the indicated altitude of 8,000. Call that MSL. Type, this is a Cessna 172 Skyhawk. TA temperature, -4 Celsius. WV is wind velocity. Our colors are off here. Wind velocity, at that altitude, wind velocity is from 245 degrees and 40 knots. All right, Jacob Helton's getting in. We'll go ahead and click the buttons for him. All right, so we're in, and we are now looking at WV for wind velocity. And what we can see for wind velocity is that we have a wind velocity of 245 degrees, 40 knots. So that's what we're looking at for this particular PIREP. All right, as we continue, it says TB, that would be turbulence. This pilot is reporting turbulence to be light turbulence between 5,500 and 7,500 indicated. That's MSL. And then it says other remarks, RM, is that he's in the clear. So this pilot is not in the clouds. This pilot is in the clear VFR conditions. So let's really have some big picture notes about PIREPs, some big picture information regarding pilot reports. Why are pilot reports so awesome? Why are pilot reports so valid? Why are pilot reports so important? Well, it's a real deal airplane, a real deal pilot that's out there experiencing this weather phenomenon. So there are so many weather forecast products to try to help us predict what we might expect when we go flying, but there's no substitute for a real pilot that's telling you what they are seeing out the window. What are some of the most important PIREPs? Good question. What are some of the most important PIREPs? I would say turbulence. Turbulence is a very important PIREP. Another important PIREP would be icing. Icing is a very important PIREP. And then the last one I really want to point out is TOPS, T-O-P-S, cloud tops. So as you're taking your notes and you're writing down what PIREPs get you the most excited, it should be turbulence, TOPS, and icing. So yeah, there's lots of products that try to predict turbulence, but a real pilot report, there's no substitute. Icing, there's a lot of products that try to predict about icing, but there's no substitute for the real thing. And then last, cloud tops. There are not very many weather products that help us try to predict cloud tops. There is not very much information for us as pilots to try to ascertain what the cloud top altitude might be. So we have a lot of weather products that help us determine cloud base information, the base of the clouds. We have lots of weather products for that. We have very few weather products that could give us cloud top information. So if you have a PIREP, that's a real deal pilot telling us our cloud top information. Why is that so handy? Because if you know the cloud base and the cloud top information, we then can figure out how thick that cloud layer is, which could really make a huge difference between a go versus no-go decision if you're an instrument pilot trying to fly in the winter. So if you're a pilot that wants to fly in the winter, you really want to try to avoid flying into icing situations. Remember, one of the requirements to pick up structural icing is that you fly in visible moisture. So the idea is that if you know where the cloud tops are and you can, as an instrument pilot, get on top of the clouds and fly above the clouds, be in the clear, no longer flying in the cloud in the visible moisture, then you don't have as much of a likelihood of picking up ice. So it's a huge, huge advantage for the instrument pilot to know cloud type information, and it's valid for a private pilot without an instrument rating to at least know more information as well. So PIREPs, how do we submit pilot report? We should submit our pilot report to Flight Service Station. The standardized frequency for flight service is 122.2. That's noteworthy to write down. And if you're above 5,000 feet in the lower 48 states, that's the standardized way to get a hold of flight service. Yes, you can give your pilot report to air traffic control, but air traffic control is notorious for not passing along that pilot report information. So as I keep clicking, it's just zooming in on those variables that we just covered. And that's a good looking PIREP. Of interest to know, you can use non-standard phraseology. You can, speak your own remarks, and whatever you tell the flight service station personnel, they will publish it. So it's really interesting. I challenge you all to go out and find some interesting PIREPs to share with us. I've literally seen some PIREPs before this. They say it's so turbulent that it's as rough as a camel's hump. I've seen some people, I've seen some PIREPs that talk about it's just smooth and sunny. So I think if find some good PIREPs out there and share them with us, that could be fun as well. Okay, printed weather forecast. So PIREP was an observation. That was not a forecast. That was an observation. Now we're into forecasts, printed weather forecasts. Many routine weather reports are used to develop the forecasts. Regional weather offices prepare over 2,000 forecasts a day. Simple thing is that you, as a private pilot, need to be familiar with TAFs and winds and temperatures aloft. There's a PIREP, and there's a TAF. Gosh, I feel like we covered this already. Do you guys have any feedback? Is this still new?
No.
No. All right. Well, let's be sure to cover this then. So what we covered was probably METARs. We did some tricky METARs. Here's a TAF for us. So TAF is Terminal Aerodrome Forecast. The whole idea is that you need to know how big of an area does TAF cover. TAF air covers 5-mile area. How often is TAF issued? TAF is issued 4 times a day. So that'd be every 6 hours. You're going to see a TAF issued. How long is TAF valid? TAF is valid for 24 hours. So when you study this TAF, this is for the Indianapolis International, and it's telling us that Indianapolis International, KIND, the first is the issue. This TAF was issued at 16th day of the month, 1433 Zulu. That's when it's issued. Now we're seeing the valid time. This TAF is valid from the 15th hour of the 16th day until the 18th hour of the 17th day. So this TAF is actually valid for more than 24 hours. Some airports that service international flights will have a 30-hour TAF, up to 30-hour TAF. Standard TAF is 24 hours. Okay, so what's really tricky about these TAFs is figuring out the appropriate times. So I really need you to pay attention to the FM, the from block. So the very first is the 16th day of the month at 15 Zulu. The next from block will be the 16th day of the month, 19 Zulu. That is a 4-hour window. So during the 4-hour window from 15 Zulu to 19 Zulu, these are the conditions we expect. We expect wind to be 150 true, 9 knots. P means greater than 6 statute miles visibility. Few clouds at 12,000 AGL, broken clouds at 25,000. That's the forecast for the 4-hour period between 15 Zulu on the 16th day to 19 Zulu on the 16th day. Now we read from block to from block. So now we're seeing the next line is 19 Zulu on the 16th day until 9 Zulu on the 17th day. So that's like 9 plus 5, 14-hour period. So during the 14-hour period from 19 Zulu to 9 Zulu the next day, we are seeing the forecast to be 170 true winds at 8 knots. P greater than 6 statute mile visibility, overcast 8,000 AGL. So that's such a large period of time, you're seeing a temporary, TEMPO, tempo. So temporarily on the 16th day from 21 Zulu until the 17th day on 1 Zulu. So there is a 4-hour window where you're going to see light rain. So during that 4-hour window, we're going to see light rain. However, during that larger time period of 19 Zulu to 90, the forecast is still going to be the same. 1708 knots, greater than 6 miles visibility, overcast 8,000 AGL. That's not changing, but they're saying that temporarily there will be a worsening of conditions during this 4-hour window between 21 Zulu and 1 Zulu the next day, where we'll see light rain. Okay, the last is going to be from 9 Zulu on the 17th until the end of the forecast, which is 18 Zulu on the 17th. So that's going to be a 9-hour window. During the 9-hour window from 9 Zulu on the 17th until 18 Zulu on the 17th, these are the conditions we expect to see that are forecasted. 130 true winds, 11 knots. P means past, greater than 6 statute miles visibility. Light rain, broken 4,000 AGL clouds, overcast 8,000 AGL clouds. So that's the whole TAF forecast here for Indianapolis. You guys have any thoughts or questions, comments about that Indianapolis TAF? So yeah.
Oh, I was just going to say real quick, because it kind of messed me up on the question. So I'd like to say that you're asking for the weather at let's say 02 on the 17th day. Would it still be the 17? I'm trying to yeah, exactly that forecast right there.
Right, and so I've been grading some homeworks, and I have a lot of y'all, missing a point on a homework assignment over this exact topic, and this is what Christian's bringing up. It's that when you learn how to read a TAF, you got to imagine the from block to the from block, the valid time till the valid time. So from the 19th hour until the 9th hour. So the 16th day, 19 Zulu, until FM from 17th day at 9 Zulu. During that 14-hour window, the forecast is 1708 knots, greater than 6 miles visibility, 8,000 AGL clouds. So if you had a question on a test that asked about the forecast for 02 Zulu on the 17th, which was Christian's example, then you are no longer within this temporary period. The temporary period only lasts from 21 Zulu until 1 Zulu, from the 16th day, 21 Zulu, till the 17th day at 1 Zulu. So if the test question asks, what's the weather forecasted to be at 02 Zulu on the 17th day, then the correct answer would be the 170 wind, 8 knots, greater than 6 miles visibility, overcast 8,000 AGL. Is that what you're getting at? Is that answering your question, Christian?
Yes, it does, sir. Thank you.
Yeah, so that's kind of a tricky one. You're going to see those types of questions on the test and on the FAA written exam, so it's better to iron out those issues today. Okay, well, we have a pretty crazy example here for Denver Airport, so I'll walk you through this Denver Airport example. Denver Airport, it's things issued on the 16th day at 14:10 Zulu. It's valid from the 14th day at 16 Zulu till the 18th day at 17. Oh my gosh, I'm trying to go too fast. This is Denver. It's issued the 16th day at 14:10 Zulu. It's valid the 16th day, 14 Zulu, until the 17th day at 18 Zulu. So this is more than a 24-hour TAF. Now I'm about to read you the forecast from the 16th day 14 Zulu until the 16th day 17 Zulu. So this is a 3-hour window where the forecast is 090 true wind, 6 knots, greater than 6 miles visibility, scattered 9,000 AGL clouds, broken 14,000 AGL clouds, broken 20,000 AGL clouds. Remember, scattered is not a ceiling. Okay, now we're about to see the forecast between 16th day at 17 Zulu until the 16th day at 21 Zulu. So that's a 4-hour window. During that 4-hour, the forecast is 330 true winds, 8 knots, greater than 6 miles visibility, few clouds, 8,000 AGL, broken clouds, 12,000 AGL. Now we're about to see the forecast from the 16th day, 21 Zulu, until the 17th day at 0 Zulu. That's a 3-hour window. During that 3-hour window, we expect to see the winds grow stronger. 340 direction true, 15 gusting 23 knots, greater than 6 miles visibility, showers in the vicinity, few clouds, 4,000 AGL, broken clouds, 8,000 AGL. Now, we're going to see the forecast between 17th day, 0 Zulu, until the FM, the next from block, which will be the 17th day at 3 Zulu. So this is a 3-hour window. So during that 3-hour window between 0 Zulu on the 17th day until 30 on the 17th day, the forecast is 340 true winds, 20 gusting 30 knots. Greater than 6 miles visibility, showers in the vicinity, broken clouds, 4,000 AGL, overcast clouds, 8,000 AGL. Now what you see is you have a temporary. So during that time period, which ironically is the same, during this time period, it says temporarily between the 17th day at 0 Zulu and the 17th day at 3 Zulu, we're going to see light showers, rain, snow. So you actually say light snow showers, light rain showers, broken 2,500 AGL clouds. So what's ironic about this example is that the from 0 Zulu 17 until the next from 003 on the 17th is the exact same time period as this temporary block. So the idea is that when it says temporarily, that means less than 50% of the time. So there's a 3-hour window where during that 3-hour window, the majority of the forecast shall be 340, 20 gusting 30, greater than 6 miles visibility, showers in the vicinity, broken 4,000, overcast 8,000. That's going to be what's happening in the majority of the time of that 3-hour window. However, there will be a temporary time period, less than 50% of that time, where during the 0 Zulu to 3 Zulu, we'll actually see light rain shower with snow, broken 2,500 AGL. So typically you see those temporaries for when they forecast the conditions could deteriorate, but it'll be less than 50% of the area of the time coverage. Goodness, if we keep moving forward, the next says 17th day, 3 Zulu until 17th day, 7 Zulu. So that'll be a 4-hour window. During that 4-hour window, the forecast is called to be 350 true winds, 22 gusting 30 knots, 1 1/2 statute miles visibility, light snow, scattered 600 AGL, overcast 1,200 AGL. However, we have a temporary, so temporarily between 3 Zulu and 7 Zulu on the 17th day, we're going to see the conditions deteriorate down to a 1/2 statute mile visibility, snow, vertical visibility 600. VV, vertical visibility. Legally, technically, that is considered a ceiling. Yes. That'll be one of your questions. Okay. Now we are analyzing the 17th day at 7 Zulu until the 17th day at 14 Zulu. That's a 7-hour window. During that 7-hour window from 7 Zulu to 14 Zulu, we anticipate the forecast to be 350 winds, true, 24 gusting 34 knots, 1/4 statute mile visibility, plus SN, heavy snow, BLSN, blowing snow, VV002, vertical visibility 200 feet. Now, temporarily during that time period, between 10 Zulu on the 17th and 12 Zulu on the 17th, there's a 2-hour window where temporarily, less than 50% of that time coverage, we expect to see the conditions change to 1/2 statute miles visibility, snow, blowing snow, vertical visibility 500. So they're saying temporarily they actually see the conditions increase, because that's a better vertical visibility. Instead of it being heavy snow, it's just snow. The visibility increases, but it's going to be less than 50% of that time coverage. Okay, and our last line of this TAF for Denver is that on the 17th day at 14 Zulu until the 17th day at 18 Zulu. So you got to go back to the top, the very first issue time. So from the 17th day at 14 Zulu until the 17th day at 18 Zulu, the forecast for that 4-hour window is 350, true, 24 knots, gusting 34, 3/4 statute mile visibility, light snow, blowing snow, scattered 800 AGL, overcast 1500 AGL. Hooray for weather products. All right, so here's winds and temperatures aloft. And we just, covered a little bit of this already at the beginning of class. We've probably heard this before, but I guess it's good for us to keep going. And the whole idea is that we can have an idea of what the forecast will be aloft. The winds aloft are different than winds at surface. In this example, there's a 3,000 altitude of 200. That's true. Call that south, southwest, 39 knots of wind. Because we're within 3,000 feet of the surface, there's no temperature information. 6,000 feet, at 6,000 MSL, we expect the winds to be 210 true, 25 knots, plus 6. That'd be the temperature, Celsius. Over here at 9,000 feet MSL, we anticipate the winds to be 200, 25 knots, and then positive 3. That's Celsius. And then here's the over 100 rule, which as I think was kind of where we left off last time, but it seems like we're getting a good review today anyway. And if you have winds that are over 100 knots, that requires 3 decimal places, and these weather products only allow for 2 decimal places for the wind speed information. So they create this coded system for us to figure this out. So I will text and draw it. The whole idea is that if you have a wind reported as 7701, that actually means that your wind is 270 degrees true, and it's actually blowing at 101 knots. How did they get that information? Well, 77, you subtract 50 from it. I didn't make it up. This is just what the rule is. You subtract 50, and that's how we get 27. So that's how we figured out that the wind is actually from 270 degrees true. Gosh, there you go. Okay. And then once you take that 50 away from the direction, we said that the wind speed was really 0.1, but then we get to add in that 100, so we can figure out that the wind was actually 101 knots. So that's the idea of the over 100 rule. We're not typically going to see winds that strong for the altitudes that we fly at in our cirrus, but that's some questions that you'll possibly see on tests. All right, so I'm clearing my numbers there, and we are doing good. Okay, so this is where I think that we need to spend our time. This is moving into severe weather reports, severe weather. Now, what you're really trying to pick up on is that severe to a Boeing 747 is a different conversation than severe to a cirrus. So the idea is that we always need to try to take into account that there are different airplanes in the world, and they may be able to have different definitions of weather. So severe weather reports and forecasts, these reports and forecasts are only published as needed. They're only published as needed. So that's one of your questions. Your questions will be, how often are they published? How often are they issued? Well, they're issued on a as needed basis. That's the answer. They're issued on a as needed basis. But then it says it still follows a schedule of sorts. So what you're learning is that they're issued on an as need basis. However, they have predictable valid times for how long they would be valid. If the weather product is valid for 2 hours and then the weather product expires, well, they might just issue a new one after 2 hours. Or if it expires and they don't need to issue a new weather product, then they won't issue a new one. So what you're learning, air mets, sigmets, convective sigmets, these advisories, they call them center weather advisories. They are issued on an as-need basis. Hurricane advisories, yeah, that's a bad deal for sure. Which we're going to hear more about is these three: air mets, sigmets, and convective sigmets. And so you need to know that air met would typically be valid for 6 hours. Sigmet would typically be valid for 4 hours. Convective sigmet typically would be valid for 2 hours. There are some exceptions to the rules. That's why I said the word typically. Maybe I should say the word generally. Generally, typically, air mets for us are valid 6 hours. Typically, generally, sigmets for us are valid for 4 hours. Typically, generally, convective sigmets would be 2 hours. That's how long to be valid, but they're issued on an as-need basis. There are 3 major types of advisories that you need to be aware of. And that would be Tango, Sierra, Zulu. T, S, and Z. And I'm sure that we'll be covering those in our next slides. Okay, so here's AirMet information. Airmen's meteorological information. This is a in-flight weather advisory. In-flight weather advisory. Again, typically you're going to see that they're issued every 6 hours for weather phenomenon, which is of operational interest to all aircraft. That's the key words for you to remember this on the test. For all aircraft. And then they could amend it as necessary. So why is it so important that we mention all aircraft? Well, you might be a Cirrus SR-20 and there might be a Boeing 747. There's lots of different aircraft and lots of different pilots. So if you see an AirMet for turbulence, for us as a single engine airplane with only 4 seats, we might really want to pay attention to that turbulence AirMet. Then you talk to the Boeing 747 pilot with 4 jet engines, you know, that pilot might look at the AirMet for turbulence and think, oh, that's a piece of cake, not a problem. You know, it might not affect their go, no-go decision, whereas it could affect our go, no-go decision. So the word all aircraft means that we're going to pay attention even as small general aviation pilots. Okay. Comes in 3 varieties. So like I was saying, there are 3 AirMets that we really need to wrap our brain around. Tango, Zulu, and Sierra. Yes, you need to know these. Tango is for turbulence. T for turbulence. Tango. It says we can get Tango, AirMet Tango, for moderate turbulence, sustained surface winds 30 knots or greater, and or low-level wind shear. So the idea is that the word moderate turbulence, the word is moderate turbulence. You'll have tricky questions where it asks about light turbulence, light turbulence. We do not see any sort of in-flight weather advisories. We do not see any printed weather products for light turbulence. So it has to be at least moderate turbulence for us to see a weather product get issued. And if it's a moderate turbulence, then we expect it to get issued as an AirMet. AirMet Tango. Okay, the next is AirMet Zulu. Zulu is for icing. So ice and beverage, good. Ice on airplane, bad. Again, the word is moderate. It's for moderate icing. So all of a sudden, if it's considered light icing, trace icing, some sort of icing that is not moderate, then you would not see an AirMet issued. Icing. And I think we've talked about it before. There are different types of structural icing. We typically say clear, rime, mixed. Frost is also a type of structural icing, but we don't pick frost up while we're flying. AirMet Zulu, structural icing. How do you know if ice is going to be an issue on today's flight? You got to have a collecting surface at or below freezing, and you have to fly through visible moisture. AirMet Zulu is one of your primary weather products that you use to predict icing. threats. So if, when your examiner asks you on the day of the check ride, what kind of weather products could you use to predict if icing is going to be an issue on today's flight? AirMet, SigMet, AirMet. These are very, very valid answers. Very good answers. But there's no substitute for the real deal. So if there's a real pilot that's issuing pilot report that says, yes, I am picking up ice, or no, negative, I'm not picking up ice, that is a real valuable resource, because this AirMet is still just the best guess. The forecast. AirMet Sierra. This is our last AirMet that we're going to speak about. S for Sierra. Think about S Sierra like you can't see, out the window. S-E-E, you can't see Sierra. So why would AirMet Sierra get issued? Well, it's because it's IFR conditions out there. IFR, instrument flight rules. You need an instrument rating because you can't see. There's clouds. So when the weather is forecasted to be less than 1,000 foot ceiling, less than 3 miles visibility, mountain obscuration, well, then they issue the in-flight weather advisory, flight service, NOAA. We're going to see these weather products get issued for AirMet Sierra because you can't see instrument conditions. So what is mountain obscuration? Well, I'm glad you asked. So mountain obscuration means that you cannot see the mountain because there's clouds. So danger, if you go flying in those clouds, you might hit the mountain. The mountain is obscured. You can't see the mountain because it's hidden with the clouds, obscured by clouds. So mountain obscuration means you can't see the mountain because of the clouds. So they classify that as they issue AirMet Sierra because it's, dangerous for, instrument pilots. Okay. When I think about clouds, we had a question on one of our homeworks a while ago. It's like, oh, if you fly into a volcanic ash cloud, well, one, don't do that. It's bad. But two, what would you do? Well, you need to turn around, 180-degree turn. That is one of the most important questions you'll get on the day of your private pilot check ride. Although it won't be about a volcanic ash cloud, it'll just be about a normal everyday cloud. And so if you are not instrument rated and you inadvertently, accidentally fly into a cloud, well, yeah, that's illegal, but gosh, what are you going to do now? What's the appropriate course of action? Well, the answer should be reverse course, 180-degree turn. And you need to know as a private pilot, what is the best way to accomplish a 180-degree turn? The answer is the turn coordinator. So remember our flight instruments, you bank the airplane standard rate turn, which is 3 degrees of heading change per second, and you're going to do a 180-degree turn, which will take exactly 60 seconds, 1 minute. So that's very, very important information. You should definitely have that somewhere in your notes throughout this course, that if you inadvertently fly into a cloud, what's your best strategy? 180-degree turn, turn around. You came from an area where there was not a cloud, get back to that area where there's not a cloud, 180-degree turn, standard rate turn, use the turn coordinator, 60 seconds, 1 minute. Which can bring us to our next weather product, which is SigMet. SigMet, significant meteorological information. So you see the word SIG, you see the S at the beginning, think more severe. So remember, AirMet started with A, it's for all aircraft. Well, now we're getting into SigMet, there's an S, it's more severe. Significant meteorological information. Non-convective hazardous weather considered significant to all aircraft. Valid for up to 4 hours after issuance. So the big words here are non-convective, non-convective. So remember, convective activity, that's those like vertical motions of heat exchange in the atmosphere, call them thunderstorms, possible thunderstorms, convective activity. So this is non-convective. So we're having some serious weather, but it's not thunderstorm related. SigMet. What are some reasons we could see SigMet? Icing. That would be called SigMet Zulu, and that would be for severe icing. Could be for severe or extreme turbulence. So that would be SigMet Tango, if they issue SigMet Tango. Also could be for clear air turbulence, Tango. Dust storms, sandstorms, those are SigMets. Volcanic ash, that is a SigMet. some of those non-standards, volcanic ash, dust storm, sandstorm, they can have different valid times. So for us, I think about, Tango, Sierra, and Zulu, turbulence, IFR conditions, icing. Those are the typical in-flight advisories that we're going to see being flatland Indiana folks. And so those time periods of 6 hours, 4 hours, and 2 hours are what we expect. But some of those other not as standard things that we don't normally see here in Indiana, like dust storms, sandstorms, volcanic ash, they might follow a different schedule. So just pay attention when you read that particular weather product and it's posted on that weather product. It tells you when it's valid, how long it lasts, when it was issued. Every weather product has a timestamp. Every product has a timestamp to let you know when this information is valid for. Okay, and that takes us to convective SIGMET. Hooray, convective SIGMET. So we've made it to convective SIGMET. This is thunderstorm activity. Convective motions in the atmosphere, thunderstorm activity. It always implies severe or greater turbulence, severe icing, low level wind shear. It says that our convective SIGMET could be issued at 55 minutes past the hour, so H plus 55, whatever hour it is, 55 minutes past the hour. But there could be special updates, so they could be issued, all sorts of time periods. They're typically valid for 2 hours. Okay, could be issued for tornadoes, lines of thunderstorms, thunderstorms of a wide area, embedded thunderstorms, severe storms producing greater than 3/4 inch of hail or wind gusts 50 knots or more. So, gosh, you thought AirMet was bad, you thought SIGMET was worse. Gosh, convective SIGMET sounds real bad. So as a small single engine pilot, we need to really pay attention to all these weather products that can get issued. And as it gets to be more and more serious of a weather product, more and more warning, we should really be leaning closer towards that no-go decision. Printed reports and forecasts. Okay, so that takes us to the end of the slideshow of 7B, printed weather reports and forecasts. Do we got any thoughts or questions about any of that?
Nope.
Very fascinating, but I don't got anything, sir.
Awesome. Well, we're about to launch into 7C, which will be the graphical pictures, and we'll be sure to spend some extra time, studying some of these graphic pictures that maybe didn't pop up in the homework correctly to begin with. But I'm looking at the clock and it seems like a pretty good time to take 10. So we'll take 10 minutes, bathroom break. We'll be back and we'll be looking at some graphical weather forecasts.
Done deal.
You guys hear me all right?
Yes, sir.
Yes.
Getting some positive feedback. It's a good deal. We're just keeping our eyes open. We're still looking for Chance. We never saw Chance today, or Isaac Nesbitt. So if any of you guys are in here and I'm missing you, speak up or forever hold your peace. Making sure I don't see any messages from them. I had issues with the Slack app today. It wasn't letting me launch our Zoom session like normal, so that was kind of strange, but we eventually figured it out. Checking my other messages to see if they're not struggling somewhere else to get in. Well, we're happy to have you back. We are getting close to finishing chapter 7. That was probably the biggest section of chapter 7, what we just did, the printed weather reports, the METARs and the TAFs, sigmets, airmets, convective sigmets. So where we're at, we are about to launch into chapter 7C, and then there's also D. So we'll have chapter 7C and D. And once we finish chapter 7, then we'll be ready for the weather test. We'll be ready for the weather test. The weather test is going to have both chapter 6 and chapter 7. That will happen once we finish our material for 6 and 7, which I don't quite think will be today, but I'm thinking will probably be next time. So I'm thinking on Wednesday, we will be completing our weather material, chapter 6 and 7. And I'm thinking that we will open up the possibility, we'll open the weather test. Beforehand, last time we had a weather test that was available, well, basically Wednesday when class got finished all the way up until Sunday. I'm not going to be able to do that large of a window. I've discovered that there are some issues, and it's not feasible for me to try to, get through all the tests, find any issues, and then still try to, then have the class on Monday. So I'm thinking that we'll have to have a deadline, if it does fall over the weekend, probably be on like a Saturday. And so that way I can have some time leaving the Sunday. So just letting you know where we're at. We are going to continue chapter 7, C and D. Once we complete that, we will then start going for the test, chapter 6 and 7 test. If things go as I plan, we'll probably open up that test Wednesday afternoon, and that would then close the test, say Saturday afternoon. That's what I'm currently thinking will happen. So that's currently what we're looking at. We'll keep you posted as we know more. Practice writtens are a huge conversation. We're getting very close to the end. So if you're not taking practice writtens and studying the material for the entire class, the practice written, it's coming really quickly. So today's April 27th. I'm just looking at my app, my calendar on my phone. And it's telling us that today is Monday the 27th. Then we'll have Wednesday the 29th. Next week, which is the 4th and the 6th, will be our last week before finals week. So on those 2 dates, on the 4th and the 6th, we're probably just going to be reviewing for the final. Bringing up together some of those tricky questions that might come out of chapter 8, 9, or 10. A lot of them are going to be math problems involving weight and balance, things of that nature. And that would take us into finals week. Finals week is going to be May 11th through the 15th. So during finals week, there will be 4 tests that are available to you. And you have to take a minimum of 3 of the tests. I would advise you just go ahead and take all 4. Each test will be a FAA written exam, practice, if you will, but don't call it a practice, it's your final. And whatever 4 grades you get, I will drop the lowest, and you must have at least 3 that are above 80%. Looks like Chance is making it after all, so we'll click the button there. We're happy to have you join us, Chance. We are in chapter 7, working on C and D. Once we complete this, then there'll be a chapter 6 and 7 test. We anticipate that that'll probably get launched Wednesday after our class period, depending on how we can get through some of this material today and make sure we get all our questions answered together. I hate to leave anybody with questions. Was there any opening comments or thoughts from anybody before we launch into graphical weather products?
Yeah, I had a question about kind of about what you just went over as far as next week. So next week, are we going over chapters 8, 9, and 10, like all together that week?
Right. So the idea is that chapters 8, 9, and 10, I'm not going to click through, detailed PowerPoints per se for 8, 9, and 10. Instead, what we'll do is I will bring in questions that are on the written exam surrounding chapters 8, 9, and 10. And we would review some of those questions that you might experience on the final that involve chapter 8, 9, and 10. So we will not click through PowerPoint presentations for chapter 8, 9, and 10. We will not have a traditional test for chapter 8, 9, and 10. What I will do is I will bring in questions that involve chapter 8, 9, and 10 that would be on the final, that would be on the real FAA written exam, and we'll cover some of those tricky questions together, and then you'll see some of those questions then on the final.
Alrighty, sounds good. Thank you.
Your questions are great. Participation, we appreciate it. Okay, well, we're still recording. Everything's going good. So we're going to try to flip the screen over here to our graphical weather products. And we'll finish up our chapter 7. And it's not working correctly. I did something wrong. Let me hit this button first. Okay, it's looking like it's better. So now you see graphic weather products. Oh, something's blinking. Isaac Nesbitt, he made it. All right. All right, so Isaac and Chance, you guys are the late stragglers. We are finishing chapter 7 PowerPoints, C and D. Once we finish those, we're going to open up the test for chapter 6 and 7. We anticipate that it'll open up Wednesday after class, and we anticipate that the test will be due by Saturday afternoon. That's if we continue with our schedule like we think, involving chapter 7 PowerPoints. That's where we're at, chapter 7C, and I'm clicking the button to make it larger for us. I'll try it again. All right, we're up graphical weather products. Okay, commonly used graphic weather products. So here we have something called a weather depiction chart. Provides an overview of VFR and IFR conditions. Most useful for determining general weather. That's one of the questions on the test. Most useful for determining general weather conditions and quickly locating areas of adverse weather. You'll see that phrase again. Prepared and transmitted every 3 hours. And I think if I click, it'll get a zoomed in picture. So here's a zoomed in weather depiction chart. So this is probably one of the charts that would not load correctly on the homework. That's why it's worth 0 points on the homework. But just to make sure to cover this with you, big topics. Every weather picture that you look at, every graphical weather product has a legend, has a key. So down here on the left, here's your legend. Here's your key that's describing to you what the symbology means. Furthermore, there are older, newer, there's all sorts of weather products. So even though sometimes they could look way different, you can always figure out what the information is trying to tell you by studying the key, the legend. So what we're learning on this chart is that they have a red solid outline. When you get a red solid outline, then that's going to mean IFR conditions. We know that because we know that IFR is less than 1,000-foot ceiling, less than 3-mile visibility. So in this picture, we have a pocket of IFR over top of Wisconsin. We have a large pocket of IFR kind of scraping this whole area. We have another smaller pocket of IFR over Western Canada. And that's where the red solid outlines are. Okay, we have a blue cloudy squiggle marking in our key, and that is for marginal VFR, MVFR, ceiling 1,000 to 3,000 AGL and or visibility 3 to 5 statute miles. So we have a small area of marginal IFR that is near, what is this, like, goodness, the East Coast. We have small pockets of IFR down here over Cuba. We have, larger pockets of IFR over Eastern Canada. And now here's the large pocket of IFR. I mean, this sucker's stretching all the way from Canada to Mexico, dang near. So you're really paying attention to what the different symbols indicate. And this is one of the questions that would not load correctly on the homework. So that's where I'm really trying to point it out to you, that you must go to the key, go to the legend on that particular weather product and ascertain to figure out what the different symbols mean on the chart. In this case, we're getting symbols of a solid red for IFR, less than 1,000 ceiling, less than 3 miles visibility. We're getting a squiggle, puffy blue symbol line to mean marginal VFR, 1,000 to 3,000 AGL ceiling, 3 to 5 miles visibility. Beyond that, this particular chart has more information, such as cloud cover. So they have a circle. So here in the southwest part of the United States, there's an open circle. That means a clear sky. Whereas over Indianapolis, it looks like there's a darkened circle. That means an overcast sky. Versus under my mouse, it looks like there's only 1/4 of the sky is filled in with the dark pie. So that would maybe mean like a few or scattered layer. So they're talking about different cloud covers from these stations on this graphical weather product. Furthermore, it has some symbols to just to the left of the cloud circle. And in this example, 2 green dots would mean light rain. Whereas if you had 3 dots, it could mean moderate rain. If you saw 4 dots, it could mean heavy rain. So in some of these examples, here's 3 dots, that would mean moderate rain. There are some other, here's 4 dots, that would be heavy rain. There's some weird symbols here where it's like a single dot with a half bracket. I think that means ice pellet. We'll have to click the next slide to see. Other things that we see on this graphical weather product involves the high pressure systems, the low pressure systems, the fronts. Here's trough, the isobars should all be reviewed. So here is showing a better depiction of what some of those cloud cover and symbols could possibly represent. So we talked about the different dots. So the really big new one here for you is the wind barb. So this is a wind barb. So in this example, it looks like the wind is coming from the northwest. And then depending upon how many bars or flags could indicate the speed. So in this example, we have 2 long legs coming off of the wind barb. So each long leg could be worth 10 knots. So this would be about 20 knots of wind that is coming from the northwest. And then here in your examples, if they had a double circle, it could be calm wind. If you had half of a barb, it could be 5 knots, a full barb, 10 knots. Here's an example of 15 knots. If you get a flag, that's worth 50 knots. You're going to see this like on the interactive charts. So when you get on aviationweather.gov and you look at the interactive weather maps, they'll use a lot of this shorthand symbology. All right, here's a surface analysis chart. Shows weather conditions as of the valid time shown on the chart. Shows locations of pressure systems and fronts on the surface, transmitted every 3 hours. So it's really a very similar idea. This particular surface analysis chart is extra fancy. Why is this one extra fancy? It's actually got radar picture on it. So this weather product is a combination. Not only is it a surface analysis chart showing highs and lows and fronts, this chart also is showing us radar. I'm not saying that's normal. That's just what this chart is showing us. So in this chart, we're having pictures of the radar. You know, the darker green, yellow, and red would be the severity of the precipitation. If it starts turning more purple or blue, it could be more mixed or snow. So it's the same idea. We're seeing the normal surface analysis chart, highs and low pressure systems, fronts, and isobars. This particular chart is also combining radar picture on top of the surface analysis chart. So this is not a forecast. This is not a forecast. What you need to really remember is that there are two different weather products. There's observations, things that are historical that have already happened, and then forecasts where they're predicting the future. Radar is not a forecast. If you get on some very fancy websites like Weather Underground, it's a really cool website. You can go to Weather Underground. It's not an official way to check weather, but it's a cool website. They might possibly have some like future cast of radar. Like the weatherchannel.com, they might have some future cast of radar. But historically, radar is not a forecast. Radar is a historical observation of what has already happened, or maybe what is happening if you got a really current picture. So here's a picture of a true radar summary chart. Computer generated mosaic of radar echo intensity. Issued hourly. Yeah, but that's really the old information. If you want to memorize that it's issued hourly, that'll help you pass the ABC multiple guess exam. But to be honest, these things are almost continuous. So you get on aviationweather.gov, you get on weather.gov, you get on weatherunderground.com. You look at their weather products and you're going to see that radar pictures are updated way more frequently than every hour. I actually have a radar app on my phone. We have radar on our ForeFlight. Typically, if we can see a radar picture that's within 7 minutes old, that's pretty good. So I'm going to say that again. If you can view a radar image that is within 7 minutes old, that's pretty good. Some of the commercial websites, .com websites, they can get you a weather picture that's up, they can get you a radar picture that's up to the minute. But when you get on the .gov sites like weather.gov, aviation.gov, you're probably lucky to get a radar shot within 7 to 15 minutes. So here's a zoomed in picture of a possible radar summary chart. Again, it's showing us areas of precipitation. What does radar show? That's one of your questions. Radar shows areas of precipitation, it shows intensity, and it shows direction, movement. Does radar show clouds? The answer is no, not really. There are some interesting artifacts. There are some interesting things that happen with a radar picture. So for example, look at this straight line beam. There's a weird straight line beam going through the southern Indiana. That is not real weather. So wherever the radar station is, for some reason it had a glitch, it had an error, it had something, because look at that straight line of green. So there are certain limitations to a radar, and that's one of the things you're seeing here. What probably happened is that the the person who's manning the station, the radar station, they have a knob that they can change for intensity. They can turn the intensity up or down. And that's what makes radar so interesting. You go to 10 different websites, look at 10 different radar pictures, and they might look completely different because everybody could turn the intensity up or down on their radar image. And for different reasons. So in this example, we have some areas of more severe weather occurring down in the southern states, Louisiana, Arkansas. So down here, we're starting to see some pockets of yellow, maybe even red. We're starting to see some areas of more severe weather. One person might want to turn the intensity of the radar really strong to really paint those pictures. Another person might want to keep the radar intensity really low because they don't want to get false returns. So this weird straight line here is some sort of false return as the radar sweeps and somebody adjusts the intensity. That can take you also into the idea of these light blue. So you see a lot of this light blue shadow hazing that's surrounding some of the areas of precipitation. What that's telling you is that the intensity of the radar is turned up very strong. So we're getting some very, 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 very light returns in that area. That precipitation may not actually even be reaching the surface. Another issue that you have with radar is called ground clutter. Ground clutter. So if you get ground clutter, that would be surrounding a radar station. So somewhere surrounding the actual radar station, you start to get some of that blue or some of the light intensities. You're not actually getting precipitation in that area. It's the ground clutter, the buildings, the trees, the obstacles, the terrain, everything that surrounds that satellite dish on the ground could possibly send back some false returns. And depending on how many false returns you see, that could give you a clue as to how sensitive the radar dish is turned up to that particular day. Some radar could show us information such as cloud tops. I said cloud tops, I said that wrong. It'd be thunderstorm tops, which would be the cloud tops if there's some significant precipitation inside that cloud. Like imagine like hail and rain getting thrown up and down in the cloud. Well, then radar could possibly show us some cloud top information, but it's really not tops of the clouds. Yes, it is. It's tops of the thunderstorm because there's so much precipitation involved in that thunderstorm. You get NE. You'll see that a lot on some of these weather products on the test. NE means no echo. So if you're looking at an old radar summary chart that says NE, that means the station is not reporting any echoes, no echoes. That means that there's no precipitation in that area. All right, radar. Pretty cool picture there. Mesocyclone, goodness, wow. Radar limitations. It can only detect precipitation. So does not detect clouds. Radar does not show clouds. Radar does not show clouds. If you got to write it 20 times on the board like Bart Simpson. Radar does not show clouds. It shows precipitation. It shows precipitation intensity, direction, movement. Now, dense returns can create blind spots. We've talked about that a few times. And the idea is that, say you have a really dense area, like a very strong thunderstorm or some dense snow. Well, then all of a sudden it could appear to be clear behind that weather phenomenon, but it's really a false because the radar beam is not making it that far because of the dense weather to begin with. So composite images can help solve this. Composite images would be that we combine the pictures, the radar information from multiple radar sites. So when you study the radar pictures on weather.gov, you can either study one particular site, and that might give you the most timely information, the most up-to-date, or you could study a composite image that has all of the weather radar stations across the country, which could be really handy information, but it takes time to stitch together all those different radar stations. So if you're looking at a composite picture that involves multiple radar stations, it could possibly be more delayed of a picture that you look at. Another composite variable could be angle. So you could have the radar dish at a low angle, or you could have it at a high angle. And it depends on what that radar operator is trying to shoot, what they're trying to depict pictures of. Are they trying to depict pictures of the lower atmosphere, the upper atmosphere? If there's very strong developing storms that go very high in the atmosphere, they might tilt the radar up a bit. So really pay attention to your legends, your keys. If you're ever on ForeFlight, you have the option of selecting whether you like composite or not, low tilt, high tilt, a lot of different options for radar. Later on, years later, when you fly an airplane that has an onboard radar, you actually have your own dial and you can tilt the radar dish as you like, whether you'd rather tilt it straight out, up, or down. Generally, you don't tilt your radar dish down when you're in the airplane. There's not any, there's no benefit of pointing the radar down. In fact, it's actually discouraged because you're painting cancerous signals all over the planet Earth. So try to, keep your radar dish pointed up more than down when you're in the real airplane. We don't have that equipment aboard our airplanes. We have Cirrus. We have like a data weather uplink. So it's through your fancy Mode S transponder. You call it FISB, F-I-S-B. That's one of the questions Sean will ask you if you take a stage check with him. And we get onboard radar information, but it comes through the satellite system through FISB, Flight Information Service Broadcast, FISB. FISB. And the idea is that our onboard weather radar picture is delayed. It's delayed at least 7 minutes, if not 15 minutes old. So those are questions you'll hear about again. Radar. Click. Okay, satellite pictures. Specialized weather satellites, they can generate an abundance of useful information. Well, that's cool. We could have photographs, temperatures, humidities, wind speed, water vapor locations. Satellite, cool, let's use satellites. So one of the most common satellite images that we look at is called visible images. We call it visible moisture. So when you click in on aviationweather.gov and you want to look at a satellite picture, you'll have one that says visible moisture. And you click visible moisture and it'll show you the presence of clouds. It'll show you the shape, the texture. You can actually kind of look at the thickness. But pro tip, it's not very useful when the sun's not up. So in this shot, you can see over here on the farther and west side of the picture, it's really dark. The sun has not came up yet. It is before sunrise over in that area. And so you're not going to see very good pictures of visible moisture because it's not visible. It's dark out. So the visible images, visible moisture, that satellite image is not going to be a whole lot of help for you if you're looking at trying to do night flying or something, around sunrise or sunset. Infrared. So an infrared satellite picture, it could show you differences in temperatures between cloud heights. It could aid in determining cloud height. Nowadays, if you get on aviationweather.gov and you look at the infrared satellite pictures, they actually have more color than this. So this one's a black and white, and in this example, they're showing you that the more white, the brighter white is showing you that it's a higher cloud. The cloud has a higher cloud top. Nowadays on aviationweather.gov, it would actually show you different colors. So it would be a brighter color. Having that brighter color, that more pop color, is going to depict to you that it is a taller cloud, that the cloud top is at a higher altitude. What does that mean to you as a pilot? It means that cloud has grown very, very tall. What does that mean? That means if it's a thunderstorm, it's got some serious convective activity for it to be able to grow so tall to begin with. It does this with temperature technology. And so you'll actually see that the colder cloud tops are the cloud tops that grow taller and taller and taller, which is going to imply more convective activity and more serious thunderstorms. Constant pressure analysis chart. So we said there's only 3 variables to weather: temperature, pressure, and moisture. We are now studying pressure. Constant pressure analysis chart. upper air weather map reference to a specific pressure level. Pressure level. So useful for high altitude operations as pilots use pressure altitudes above flight level 180. So it's kind of a little bit beyond us. It's a little above our heads, if you will. We don't fly this high in the atmosphere. We're probably not going to use this chart a lot, but it still could be something that you could wrap your brain around and find as useful information. Why? Because whatever's going on in the upper atmosphere is going to have an impact on what's going on here in our lower atmosphere. So this constant pressure analysis chart, it's issued twice daily. It says 12 Zulu and 24 Zulu. And there are 4 different constant pressure charts according to this slide. We have an 850 millibar, 700 millibar, 500 millibar, and a 300 millibar chart. So we know that standard millibar hectopascal pressure is 1013.2, 1013.2. If you call it 1,000, rough number, that means at sea level, we should be somewhere close to 1,000 millibars. So 500 millibars would be cut in half. That's where flight level 180. That's where the airplanes enter alpha airspace and they change their altimeter to 29 or 902, and they don't use the local pressure settings at low altitudes anymore because now they're at higher altitudes. So what you're seeing is that if you want to study the 500 millibar chart, that would be pretty equivalent to studying what the pressure systems are doing at about 18,000. Why is this important information? Well, things that we already know. We know that low pressure systems circulate counterclockwise. We know that high pressure systems circulate clockwise. We know that the winds aloft follow the isobars. The winds at the surface get deflected because of surface friction. So if you're going to be trying to plan a flight at 5,000, 10,000, 18,000, or 30,000, you could study the pressure chart for that altitude and get a more accurate idea of where the pressure centers are and how they are rotating at that particular altitude. Because our world is a 3-dimensional picture. So we're looking at a 2D picture, but we have to imagine there is a 3rd dimension of altitude. So you could try different altitudes with the constant pressure chart to get an idea of how the pressure systems change with altitude. Again, with every chart, you want to always read the legend. And if you're trying to take a written exam, ABC multiple guess, and you have some weather chart in front of you, and you're like, man, I've never seen this thing before. Well, first thing you need to do is read the legend. Read the legend, figure out what this chart's actually showing to you, then reread the question and try it again. Significant weather prognostic charts, SIGWICs, if you will. So primary graphic aviation forecast product used to aid in planning to avoid areas of low visibility, turbulence, or icing. So USGA has to be US government. It's a graphic aviation forecast. We're going to use it to avoid areas of low visibility, turbulence, icing. It's available at multiple levels and multiple time frames. So what's going on now is that we're basically talking about some of those exact same in-flight weather advisories that we had earlier. Remember AirMet, SIGMET, convective SIGMET. Well, some of those significant weather advisories could now get depicted graphically. So here's a low-level SIGWICS prog chart. And this is really important. You're going to have multiple questions on the test about this. So here it is zoomed in. What I'm really trying to point out to you is that step 1 is figuring out which panel to focus on. There are 4 panels to this chart. Okay, so the top 2 panels, the bottom 2 panels. The top 2 panels. The top one says low-level SIGWIC, 12-hour. So this is a forecast. 12 hours into the future, what's going on low level? That's the top left panel. The top right panel, low level SIGWIC, 24-hour. So 24 hours from now, what's the forecast for low level atmosphere? That would be the top right chart. Okay, what's going on in the bottom panels? It's really kind of small, so I'm trying to do my best to look at it. It's telling you here, it's issued at such and such, 18 Zulu, Tuesday, November 17th, and then it's valid at, say, 0 Zulu, Wednesday. And then the next panel says it's valid at 12 Zulu. So the idea is that when you have a question on the test, ABC multiple guess, or you're trying to plan a real flight, you need to have an idea what time period am I really trying to focus on, and then you got to match it up to the correct panel. The difference is that the bottom two, I think, is what you would call surface, and then the top two you would call low level. So in the top two, let's study the top two. Low level SIGWICs. It's telling us that we have a lot of different symbols. Again, read the legends, look at the keys. You can see that they have a dark red, and they're telling us that means IFR conditions. You know, ceiling's less than 1,000, visibility is less than 3. There is a blue cloudy squiggle. That's for marginal VFR. 1,000 to 3,000 AGL ceilings, 3 to 5 statute mile visibility. Okay, now we have a new dash yellow. Dash yellow says moderate or greater turbulence. It's kind of hard to read. I really got to zoom in there and try to strain my eyes. We have a squiggle purple, and that's saying freezing level at the surface. And then we have a dashed green that says freezing level above mean sea level, MSL. So you'll have questions, and this was one of the homeworks that didn't work out correctly. We had a question on the homework that was asking about what's the freezing level over Florida. So for example, in this picture, there's a green, dashed green, and it says 160. So the freezing level in that area for the 12-hour low-level SIGWIC says the freezing level of Florida is going to be 16,000. We got this symbol here. It's like a hat. It's like a mountain, and it's got little legs. That's for turbulence. That's a symbol that means turbulence. So here over Mississippi, looks like 180 and it has a slash. That slash means, you know, it has to do with the altitude. So 18,000. Turbulence, 18,000. I want to say and below. I want to say it means and below. So I'm just looking at these weather products on the top two panels, making sure we're not missing anything. We've talked about how the green is going to be freezing levels. So anywhere you see the green dash, that's the freezing level. We said the yellow is going to be turbulence. So here on the 24-hour low-level SIGWIC, there is a yellow turbulence, and that yellow turbulence looks like here, this one says 24,000 versus down here, you're more of 18,000. So it really just kind of depends on which line you're studying.
Hey, sorry to interrupt,
Yeah, get it.
but Isaac put in the WhatsApp
Hey,
Slack.
back, man, don't worry about it.
Oh, no. Oh, gosh. Poor Isaac. He's struggling. He's having a bad connection. He's not in the session. If I'm not just letting you know, well, that's nice. At least he's letting us know. He's trying. Some days we fight technology harder than others. I'm going to do my best job to record these and post them for you. So if that's helpful, I'm also happy to answer questions. You know, you can email me. We could Zoom privately. I have these office hours where, you know, I sit around, you know, in front of the computer and nobody ever logs in to ask questions. So we'll do what we can to make it right. Oh, this is not what I wanted to look at. I think it's what we're focusing on. Gosh, so we've covered the SIGWICs at the top. We're making our way over here to look at the bottom. So same conversation applies. Study the legend. This legend's showing you what the different colors could mean, whether it means that there's a chance or whether it's likely, whether it's going to be rain or snow or mixed or ice or thunderstorm. The darker the color, it's more likely. The lighter the color, it's more of a chance, less than 50% of the area. And then the same things like always, low pressures, high pressures, fronts, isobars. All right, we'll keep moving. Mid and high level SIGWIC prog charts. Huh, Okay. So we might zoom in, we might not. Yeah. So this is like mid to high level. So again, this is kind of above our service ceiling. This is kind of higher altitudes than we'll see for our Cirrus aircraft. And the idea is that we're seeing some very strong wind currents. So over here on the right, this is probably the picture we're more used to looking at with America. And so it's really kind of almost like, you know, a jet stream shot is really what we're seeing here. So we have the polar jet stream on this day, looks to be about 31,000, and it's got two big barbs. We said each big barbs were 50 knots, so it's over about 100 knots of wind at 31,000, moving from the west to the east, versus the lower, which we'd call the tropical jet. The tropical jet on this day looked to be about 36,000, and you're seeing it move more like 110 knots over here on the left by Mexico, and then probably something more like 90 knots. And then it bumps back up here around the Gulf, back to about 210. And I'm just getting that information by looking at the barbs. Like, remember that big flag means 50 knots. In this picture, we're seeing other things such as, see, it says embedded. So it's talking about thunderstorm convective activities. They have a red poofy symbol for convective activity. All this is implying altitude information, 39,000, 34,000. Here, this is the turbulence information, 34,000. Here's an L, that's where the low pressure center is. Here's an H, that's where the high pressure center would be. So I don't think you're going to see this chart on the test. I don't think you're going to see this chart on the private pilot written exam. But, you know, we're exposing you to a lot of weather products that you'll, you know, theoretically use for the rest of your life, whether you fly, you know, bigger airplanes, you know, something later on. So commonly used weather products. So this takes us to convective outlook chart. So this is our convective outlook chart. This chart has changed a lot over the years. What you're currently seeing on this chart is something like this over here on the left. Unfortunately, sometimes you have very old, outdated charts that you have to use to get through the written exam. So nowadays, it's very nice, it's very colorful, it's very simple. And it helps me out. I can see the areas where it's shaded and where it's not. On some of the old-fashioned charts, there's no color. It's just a black line and it has an arrow. And we were told as pilots when you first learned this, that you pretend your airplane is on the line pointed in the direction of the arrow. And then the area to the right is inclusive. The area to the right is where they are depicting the possible conditions. Nowadays, they color code it so it looks way easier, but if you ever had to look at an old chart and figure it out, that's what you'd be looking at. So we have some areas where there's like thunderstorm chance, marginal with slight, and you know, bad, worse, less worse, just on that spectrum. So this is where you're going to see the most convective activity in this picture, Louisiana, Arkansas. And then as we get out here, it's slighter risk, marginal risk, light risk. Here's the tricky one down here. You see the Florida tip? And that's why I told you earlier, it's really tricky because there are some weather products on the test that would just have one line and the arrow points up. And you would have to pretend that your airplane's on the line, and you would have to imagine the area to the right is the area that they are depicting as risk for convective activity. All right, graphical weather products. Forecast winds and temperatures aloft. So this is just a graphical picture of the exact same thing that we covered earlier in textual format. So here it is zoomed in a bit for us. We're seeing that we could have areas. So they start, you know, over here on the left, you study the legend, look at the key. The left, it shows starting as a gray, and then it turns into light blue, dark blue, green, yellow, red. And then finally it gets, you know, to be that white or that gray again. And that's when it's getting really strong. So in this picture out here out west, you know, like Las Vegas area, there's really not a lot of wind. There's nothing very strong. And then as we get further away, we start to see more of the blue turning into green, turning into red, and then encompassing this gray and white area where the wind is actually stronger. So in this picture, say Illinois, the wind barbs are pointing down. So that means the wind is coming from the south. And with this picture, it has a flag, which is worth 50, and say a small barb, which might be worth 5. So there's about 55 knots of wind roughly coming from the south for Illinois in this area. And this would be a 12-hour forecast for 5,000 feet, flight level 050, call it 850 millibar chart. Okay, same idea over here on the right. This one seems to be more of a temperature information. So it says forecast, tells you the valid time. This one has a nice color chart. I mean, in my experience, I don't really always see a whole lot of colors, but you know, they're always changing the charts. It's nice to have some colors on our screen today. Temperature, you guys know how to read temperature. 48. Seems like a Fahrenheit deal today. That'd be Fahrenheit numbers. And ADDS, that's the Aviation Digital Data System Service. And we know that by aviationweather.gov. So that'd be the website. It's one of your favorite websites, aviationweather.gov. Icing, huge topic, icing. Let's see. So we got a few different icing products here that could help us out. The top left, when you go on aviationweather.gov and you click down forecast and you click down icing, this is one of my favorite products to use on the top left. But it will tell you, it has a disclaimer when you click on it that this is not your primary go, no-go decision. This weather product is not your primary go, no-go decision product. What product should be your primary go, no-go decision? Should be AirMet, SigMet, Convective SigMet. Those should be your primary weather products that you use for flight planning purposes. These graphical products are created using those fundamental products, and these are for situational awareness only. What's really interesting about this icing product is that you can change it and interact with it on the website, and you can change altitudes. So you could actually focus on 5,000 feet. You could focus on 7,000 feet. You could focus on certain altitudes, which could really help you in your awareness of what the bigger picture is. What you're learning about this icing product is what the different colors could mean. So again, white would be none, you know, light blue to dark blue, trace ice, light ice, moderate ice, heavy ice. You're seeing some of the different, again, you just got to read the legend for every single weather product. And on this one, you know, a 0 with a slash, negative, no ice. You get a U with just a single U, could be trace ice. You put 1 slash through it, could mean light ice. You put 2 slashes through it, could be moderate ice. And this is the new thing that we really need to pay attention to. SLD, supercooled liquid droplet. Think about that like freezing rain. Think about that like supercooled liquid droplet, freezing rain, clear ice. It develops really quick. SLD threats. So when you get these SLD threats, which comes into a red crosshatch color, that's where you're going to see some serious icing threats. The problem with this picture, it tells you right here in the title, this particular pilot who brought up this icing product, they're analyzing a very large segment of the atmosphere. They're analyzing 1,000 feet MSL up to flight level 300. So they're analyzing 29,000 feet worth of atmosphere. So it makes this icing picture look really bad because there's, you know, a lot of chance to get icing anywhere within 29,000 feet of altitude change. So for you as a private pilot, I would dial down your variables to just include 5,000, 3,000, 7,000, 9,000, you know, only smaller pieces of the atmosphere, and then your information would be more relevant for your flight. Over here on the right, we have freezing level information. Top right, freezing level information. So this is really good, handy stuff. You'll have questions on the test that ask, what is the freezing level? So we already looked at one chart that shows freezing level. This one's colorful and nice as well. So here in Indiana, we're kind of part of this like orange beige. So that orange beige seems here to be something like, you know, somewhere between 11,000 to 13,000 is where we expect the freezing level for Indiana, which could be different than Florida. Florida is like red, so the red freezing level might be more like 15,000 or 17,000 down in Florida. And this is a nice quick way to get an idea about freezing level information. Again, these are graphics that are designed to aid in situational awareness. They are not your primary flight planning tools. Your primary flight planning tools should be the AirMet, SIGMET, convective SIGMET. And with that, I tell you that when you get AirMet Zulu, when you get SIGMET Zulu for icing information, yes, it will include freezing level information. Down here in the bottom, this is an older style chart, same idea. They're showing you freezing level information. So in this style, it's showing you 0 degrees Celsius, which is freezing level, to roughly be about 12,000 feet in this area. So in this line, there's about 12,000 foot. That's where your freezing level would be. Versus as you go farther north and it gets colder, this line might be depicting your freezing level to be something more like 2,000, or over here it could be more like 8,000, over here it could be 4,000. They have a special color, kind of this purple lavender, and they're saying that the freezing level is at the surface. Again, freezing level at the surface. So if the freezing level is at the surface, then that means, yeah, it's cold enough to ice at altitude. Icing, freezing levels, graphic weather products. So this takes us to aviation forecasts, clouds and surface. This will probably be our last slide. What we're seeing here is, okay, so we'll call it AF, aviation forecasts. Years ago, we had a product called area forecast. So on the test, the ABC multiple guess, you might have old questions that involved old weather products that don't exist anymore. So the idea is that years ago, we had area forecast. An area forecast would be a textual product, and it would cover several states large, and it would explain to you freezing levels, synopsis, outlooks, clouds, weather. Now they're creating more graphical products, and this is what they're using to substitute. We don't have area forecast no more. Area forecast is dead, it doesn't exist anymore. So now we typically use like GFA, graphical forecast analysis tool, things of that nature. And here's some of those possible products that we could see on aviationweather.gov. We could have one for clouds, we could have one for surface. These are new products, just like every other weather product. What you need to do is you need to study the actual chart. You need to look at the chart and figure out what's the valid time, when's the issue time. These forecasts say it's a snapshot every 3 hours, and it replaces the old text-based area forecast. Here it is zoomed in a little more thoroughly for you. And this is one of the very few weather products that could show you cloud top information. It's not accurate. It's not a historical observation. This is their best job of forecasting what do they think the cloud tops might be. But they're not that good at forecasting it. So PIREPs are the best. So in this example, you can see the cloud graphical forecast tool where they're showing the bases and the tops. And they're even graphically showing you where it's darker. Same idea over here, surface. This one's showing you more of the pressure systems and the winds. And they even got the little, 2 blue snowflakes for light snow. The green commas for drizzle. There's a triangle shape here. It's like a circle with a triangle, upside down triangle pennant, that means the word shower. So when you have an upside down triangle pennant, that means the word shower, like snow shower, rain shower, things of that nature. So we're probably leaving off there. There's really only about 1 or 2 more slides for that chapter section. So what's going to end up happening is we're going to finish chapter 7 next class period. There's going to be a chapter 6 and 7 test launch on Wednesday afternoon. And I'll create a due date for that of Saturday, because that's what I told you guys I would do, Saturday afternoon, Saturday evening. And next week, we'll, review some of this weather, and we'll be, covering, some of the tricky questions from 8, 9, and 10 to prepare you for the final. So I realize we're out of time. I'm not trying to hold anybody up. If you got to head out, that's fine. If there's any thoughts, questions, or comments, I'm more than happy to address them and answer any questions for you all.
I'm good, sir. Thank you.
Hey, thank you for the input. Hope you guys have a great day. It's kind of beautiful out there. Go soak up some sunshine.
Yeah, you too, sir. Thank you.
Thank you much.
Hey, thank you.